Hello everyone, my name is Martin and I wanted to share a presentation that I've held at Risk Conference, an IT security event a few days ago. The presentation was not recorded, so I had to reconstruct, but still, I hope you'll find this video interesting because it says a lot about data anonymization and contains a demo of BizDataX, a tool that is developed by Ekobit, the company I work for. So, let's start. Every company I worked for during the past 20 years, some of them were big and some were small, and I was in software development area most of the time, regularly used copies of production databases to support software development and testing. Most of us had access to sensitive data such as names, addresses, national ID numbers and similar. We knew this was not okay, but we behaved as if we had no choice. We needed data to be able to do our jobs. And then came the GDPR and other laws and regulations banning the practice of using sensitive personal data in such manner. And now what? If we are not allowed to use production clones, what data should we use then? Should we start producing synthetic data? Is that even possible? Or alternatively, should we make our testing and development environments as secure as production environments? Is that really possible, and how much would it cost us in money and effort? Or should we make our software people sign a pile of NDAs? The point is that even if we could make this work, this is not a solution because using production data is a violation of GDPR and other data protection policies, period. I have mentioned GDPR, and GDPR contains definitions of anonymization and pseudonymization. In short, if we could change data in a way that individuals are no longer identifiable, then we would be good. In other words, if we could change actual names and addresses, replace them with something else, that would be okay. While it may be obvious that we need some random names and account numbers instead of real ones, it may not be obvious that this might not be good enough. It's necessary, but may not be good enough. The problem is with indirect identification. The more data we give, the risk for identification becomes higher. And generally speaking, doing the anonymization or pseudonymization the right way may be quite a challenge. Depending on the maturity level of masking operations, your organization could be in one of the 4 stages. If you are using production clones, in essence production data for testing and development, you are in stage 1. Some try to develop their own anonymizations, usually try to produce SQL scripts to do the job. And the problem with scripts is that they tend to become complex if one wants to do proper anonymization. So usually we end up with a poorly masked databases instead. This is, in my opinion, even worse than not doing masking at all, because you might forget that you did poor job with anonymization, and poorly masked clones could become accessible to audiences that were not meant to have access to sensitive information. Our projects, that would be BizDataX implementation projects, usually lead to masking done right stage first and to process stage when we are done. We start with the discovery. That would be a systematic process of searching for sensitive information, continue with thorough masking, and end with some organizational changes and processes. For example, we need to change the masking when systems evolve. When a new table or column is added to the database, someone needs to check if that table or column could contain sensitive information and then proceed accordingly. Let's take a look at an example. Let's assume that we have to mask a core banking system. The system would track customer information. It will also track transactions together with corresponding account and credit card details. We have 5 tables and around 10 columns per table, altogether 50 columns. There are some columns that are specific. For example, customer ID in customer table is primary key, while customer ID in account table is foreign key. The pair represents a relationship between the two tables. Account ID is similar, except that in this case we have two relationships between account and transaction tables. Columns and relationships like this are easily identifiable. In 99% of the cases we just have to read the information that already exists in the database. And now comes the tricky part. First name and last name fields contain sensitive data and could be related when we compare values from customer and credit card tables. Information like this, the one regarding the sensitivity and this application level relationship, will not exist in the database. We may also need to discover that these fields have to stay in sync over customer ID. The challenge is even bigger if some of the sensitive data is stored in files. Let's say that we have some CSV files again containing IDs and names. The discovery process needs to take that data into account as well. So we need information about relationships between tables in relational database and files. The model that I'm showing you is very simple compared to what we have to deal with during real-world projects. Nevertheless, it is complex enough for me to be able to explain the principles and challenges of anonymization. I'll refer to that model during a demo. The demo will be based on BizDataX tool. It will start with model import and discovery and continue with specification and implementation of masking. I'm showing you the web UI of the tool, and this is the Chrome browser. BizDataX enables you to gather information about anonymization projects. We'll create one new demo project, which is a collection of information important for masking. We have information about data sources, that would be databases, sensitive data discovery, testing, and some reports. Let's create, or better to say, import one new data source. We'll name it DemoDB. In this case, on my demo machine, I have MS SQL Server DemoDB and will provide a connection string. Information about tables and columns is imported from the database metadata. We can continue with discovery. That would be the process of searching for sensitive data. BizDataX enables you to define rules. For example, you can take random sample of 10,000 records and check if values exist in list of first names typical for US. Email rule uses the same sampling but does not check the list. It checks if values contain monkey character and represent a valid email address. Execution of the rules yields findings. That would be columns which contain sensitive information. Names rule yielded 7 findings organized by data source, schema, table, and column. Hit rate is the percentage of records in the sample that contained names from list of US names. By sorting descending by hit rate, we get first name and email from customer table on top, first name from credit card table follows. We can fine-tune the results. Specifically, we can mark fields with hit rate 100% as hit or sensitive, We can also take a peek at sample data, which in this case really is a set of US names. If we do the same for email column, we'll notice that emails in this case also contain names, so we'll mark that as sensitive as well. We'll quickly mark first name from credit card table as sensitive. What about city? If we take a look at sample data, we'll see that only some of the values look as names. But this column really does not contain names, so we'll mark it as miss. Once we do this for all the fields, we'll filter only sensitive stuff to add some masking implementation requirements. We can specify what needs to be done with first name. For example, we want random US names. For email, we want a combination of first name and last name plus monkey plus domain so that it looks like an email. We want another first name field to be random, but this time we want it to be in sync with another first name column. And all this information can be listed in specification part of the portal. The data is organized by data source, schema, table and column. General information about masking and detailed descriptions are easily accessible to implementers. UI for implementers is a bit different. Workflow design surface is in the middle. Toolbox is on the left side. We can define masking rules by dragging items from the toolbox to the design surface. We can specify the list to be used for first name field, that would be list of US names. Similarly, we'll use list of last names for the last name field. We'll use a text concatenation formula for the email address, making email from first name, last name and suffix as specified. If we wanted gender-specific first names, we would have to use conditions. Conditions are also toolbox items. We have to drag them to the design surface and then define the condition details. List also has to be filtered to include only male names in condition branch. We can copy paste that to default branch and then change the list filter so that in this branch we get only random female names. We could continue adding implementation details like this, and then we would end up with a package. Package has a name, steps like subsetting, masking, synthetic data. We worked with masking only, and now we will check the results. By clicking on Execute button, we start the execution of the package. During the execution, we can check the status in real time. We can see steps and statuses, errors, statistics, and similar. Performance statistics and overall status is also shown. Some details about data quality are accessible. Let's now take a look at data. We'll check the data in the database. At the beginning, we have names like Claudia, Kent, Jamie. Masking creates a new copy of the database, and names in that copy are anonymized. These would be Perla, Darlene, and Kelsey for female customers, while Aaron, Easton, and Austin would be there for male customers. Email addresses would be a combination of first and last name, as expected. What I have shown were two BizDataX components: the portal, which is a web UI for data source and anonymization project management, including discovery, specification, and execution monitoring. I have also shown the designer, which helps in defining the implementation details. BizDataX does it end-to-end, supports you from the very beginning when you have to find sensitive data and specify how to mask it, but it also helps you to with lists of replacement values and other algorithms for data masking. There is a whole lot more in the box. For example, we also support test data management, which is something I could show in another demo. One thing that frequently pops up during Q&A sessions and technical talks is performance. The numbers here are from a real-world project. Masking was done on 4 tables in parallel using bulk inserts into temp tables with constraints and triggers suspended. There is a lot of tricks that you have to do to get good performance, but you'll probably have to do it for 10 or 20 biggest tables only. The goal is to get processing speeds of billions of records in hours, so that masking can be done during one night on top of the relevant dataset for testing. BizDataX was designed from ground up to support enterprise-scale databases. We work with banks like Erste, Raiffeisen, and Fonessenbank, a part of BNP Paribas. There are government agencies, transport and logistics companies on the reference list, but most of the customers come from the financial industry, are either banks or credit card processors. I hope you found this presentation interesting and would be happy to answer any questions that you might have. I encourage you to visit our web, subscribe to our channels, or contact us directly for more information.